Hello everyone, in this video we'll be solving problem 136 single number. The problem statement is given a non-empty array of integers nums where every element appears twice except for one element. Find that single one. The add-on to the problem statement is that we must implement a solution with linear time complexity, which means O of n, and use only one constant extra space, which means the space complexity should be O of 1. Looking at example number 1, where the number of elements are 2 to 1, the output is 1 because the value 1 appears only once. Similarly, in example number 2, the only element that appears once is 4. Rest 1 and 2 are appearing 2 times. The constraints that are given to us are about the length, the value, and each element in the array appears twice except one element. So it is not possible for a single element to appear thrice. It will either be one time or twice. There are two approaches to solving the problem. One being the basic hash set based approach, where we'll add all of the elements into an hash set, and if the element already exists, we'll remove it. And after the entire iteration is done, we'll be left with only one element which did not appear twice, and we can simply return it. Let's do a couple of runs to understand how this will work. We'll use the first example, starting with my pointer at I is equal to 0. The value is 2. Does it exist in the hash set? No. So I will add it and increment my pointer. So I is 1. Corresponding value is 2. Does it exist in the hash set? Yes, it does. So we'll remove it. So my hash set is empty now. We'll increment our I, so which is now pointing at 1. Does it exist? No. So we'll add it. We are done with the iteration, and at the end, we'll be left with only one element in the hash set and which we can return. This solution has the time complexity of O of n, where n is the number of elements in the input array, and the space complexity is O of n. As we are building this hash set, and in the worst case scenario, we could end up having a huge hash set with the same number of elements as the input. As the problem statement is asking us to solve the problem with only one extra space, let's think about how we can improve the solution. Another way to solving the problem is using bit manipulation by XORing operation. If you're not familiar with XOR operations, the way it works is if the two elements are equal, that is if it is 0 and 0, the output will be 0, or if it is 1 and 1, the output will be 0. But if the values are different, then the XOR operation will result in 1. I know it is difficult to contemplate how will XOR help solve this problem, but once we understand how this works, it is very easy to implement. Let's use example number 2 for solving the problem. I'm writing it vertically so that we can represent each value corresponding binary form. 4's corresponding binary form is 100. Similarly, I'll write it down for the rest of the numbers. Here's the binary representation of all the numbers. So we need to start XORing the numbers next to each other and save the results. So between 4 and 1, we'll start the XOR operation. Whatever is the result, we'll save it in a different variable. Then we'll XOR this result with the next value. Whatever is the output, we'll save it back into the result and continue that. The idea is that in the entire collection of input numbers, if there are two numbers which are equal, they will cancel out each other. For example, if we XOR 2 and 2, as they are equal, the output will be 0, 0, 0 based on this table. Similarly, if you look at these two ones, the output will be 0. After the entire operation is done on all the numbers, we'll be left with only the bit representation of the number which appeared once. Another way to look at it is at a column level, if we do the bit manipulation or do an XOR operation, we'll only get the output of the number which was unique. So for the last column, the XOR operation will be 0, as these two and these two will cancel out each other. For the second column, the XOR operation output will be 0 as well. And for the last column, the XOR operation will result in 1, and its corresponding equivalent is 4, which is our unique number in the array. So it does not matter if the given input is in an ascending order or a descending order or sorted in any way. The XOR operation on all the bits will give us the unique value that was there in the collection. With this solution, our time complexity is O of n, as we still need to iterate through all of the elements once and calculate its corresponding binary representation and do an XOR operation. But our space complexity has been improved to O of 1, as we are doing an XOR operation on two numbers and saving it into a result variable. I hope you were able to understand this XOR operation and how it helped solve this problem. Let me show you how we can implement this using C#. In this method, I start by adding a couple of validations to make sure the input is correct, and if not, then I'm returning 0. Then I'm initializing a new variable result and setting the default value to the first element in the array. Then I start the for loop from index 1 all the way to the end of the nums array, and then doing an XOR operation on the result and the current number that I is pointing at. Whatever is the output, I'm saving it back into the results variable, so we can use it for the next iteration or the next run. After the for loop is complete, I will have the output in the results variable, which I'm returning at the end. This solution, when submitted on LeetCode, beats 100% of the submissions in terms of runtime, and in terms of memory consumption, beats nearly 89% of the submissions. Thank you for watching this video. I hope you were able to understand this explanation and the solution. The link to the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.